Good morning, students. In this video lecture, I am going to discuss the quantum mechanical model of atom. Now, first of all, what is the meaning of quantum mechanical model? You know, according to Bohr's model, electron is mainly treated as your particle, and the Bohr's model depends on your classical mechanics or Newtonian mechanics. Classical mechanics means we treat electron as a particle, but we know from the de Broglie relationship, microscopic objects like electron, proton, neutron, etc., they have your dual behavior, that is your particle nature and the wave nature. And also from the Heisenberg uncertainty principle, we know that it is impossible to determine the exact position and the velocity of an electron simultaneously. It means electron is not truly a perfect particle, but it also behaves like a wave. So Schrodinger in 1926 formulated a wave equation known as your Schrodinger wave equation. Now, what is this equation? This equation is d2 psi by dx square plus d2 psi by dy square plus d2 psi by dz square plus 8 pi square m e minus v by h square psi is equal to 0. Now, Schrodinger equation is an equation of second order. I hope you know the meaning of differential equation of first order and differential equation of second order. It is a second order differential equation. In this equation, your x, y and z, x, y and z, they are axes of Cartesian coordinates. This m is your mass of electron, m is your mass of electron, E is your total energy of electron, total energy of electron. This psi is actually wave function for electron. This psi is your wave function for electron, which is also known as your eigen function. And this actually d2 psi by dx square, what does it mean? It refers double differential. It refers your double differential of psi with respect to coordinate x, position x, and similarly d2 psi by dy square, it means double differential of psi with respect to coordinate y, and same for your z. And pi, you know, it is 22 by 7, and h, you know, this h is your Planck constant. So this is basically your Schrodinger equation. Now this Schrodinger equation in very short form, this Schrodinger equation in very short form, we can also write as h cap psi is equal to your E psi. Now E again for energy and psi for your electron wave function. Now this h cap, this stands for your Hamiltonian, this is your Hamiltonian operator. It is a mathematical operator known as your Hamiltonian operator. Now if we consider this Schrodinger equation, this is highly informative about your atom containing one electron like hydrogen. Now how this Schrodinger equation is applicable for hydrogen atom? If we solve this Schrodinger equation, so after solving Schrodinger equation, we get energy levels. We get energy levels of fixed energy. Now the question is, if somebody asks you how we can solve Schrodinger equation, the answer is the solution of Schrodinger equation is very difficult and it is not for your use. Simply we can say it is beyond of your scope. You will study in higher classes that what will be the solution of Schrodinger equation. But the solution of Schrodinger equation, will give different energy levels, levels for electron, which is characterized by three quantum numbers. That is principal quantum number, azimuthal quantum number and your magnetic quantum number. Means the different energy levels which are obtained by solving Schrodinger equation, they are characterized by a set of three numbers. They are NL and your ML, which are known as your quantum number, as they specify, as they characterize different energy level for an electron. However, for your information, the fourth quantum number, that is your spin quantum number, it is obtained from spectroscopy. Spin quantum number have no relation with your Schrodinger equation. Now, each energy level is associated with a fixed value of psi. That is your wave function. Now this psi is your electron wave function. But this psi has no such physical meaning. This psi had no such physical meaning. However, your psi square, this psi square is very important. This psi square is very important, and it refers the probability density of electron. It refers the probability density, or simply called you electron density. Probability density of electron in a region, and that's why psi square is also referred as atomic orbit. Therefore, psi square is nothing, it will refer your atomic orbit. Means psi का यूज है, बट psi का उतना यूज नहीं है जितना यूज आपका psi स्क्वायर का है. कभी कभी पूछता है क्वेश्चन में, राइट द फिजिकल सिग्निफिकेंस ऑफ psi एंड psi स्क्वायर. तो यू हैव टू राइट कि psi stands for your electron wave function. Psi stands your electron wave function, which has no physical meaning, but the square of wave function. Square of wave function will give, or it will refer the probability density of electron around the nucleus, and that's why it will refer your atomic orbit. Now in this Schrodinger equation, the one term I have used is your V. This V is your total potential energy. So actually this E is your total energy and this V is your potential energy. So you can say E minus V is your simply kinetic energy of electron. Now the main outcome of this Schrodinger equation, that is the concept of quantum number and the concept of your orbital. So you can say the significance of Schrodinger equation is significance of Schrodinger wave equation is number one. It gives the idea of, simply it gives the different energy level for an electron. That is the first outcome. Second outcome, it gives the concept of quantum number, that is your NL and ML, that is principal quantum number, azimuthal quantum number and magnetic quantum number. Third point, it gives the idea of atomic orbital. Means, as you know, from the bare mechanical model, both the position and velocity, of an electron is not accurate. So there is always a probability of finding electron. Since their position is not accurate, since their velocity is not accurate simultaneously, so we have a probability of finding electron. So it is related with the probability, and that's why electron probability will refer your atomic orbital. The electron probability will refer your atomic orbital. The second, so this psi square, it gives the idea of atomic orbital which will refer by your psi square. So psi square is nothing, it is your atomic orbital. So this is your main idea of Schrodinger wave equation in brief. Now even this Schrodinger wave equation will not satisfy each and every aspect for a मल्टी इलेक्ट्रॉन एटम. अगर एक से ज़्यादा इलेक्ट्रॉन है किसी एटम में तो उस केस में हमारा श्रोडिंगर इक्वेशन ये वाला लागू नहीं होगा, बिकॉज इट इज ओनली फॉर योर वन इलेक्ट्रॉन एटम, दैट इज योर हाइड्रोजन एटम. थैंक यू.